Hello, myself Mosam, and today we will learn about current electricity. Current electricity is an important topic in electrodynamics, and we will learn about some terms in this session. What is a current? First of all, the simple current. Current is basically the rate of flow of a charge is called current. That, for example, there is a stationary charge, it is not moving, then there is no current, there will be no current. If the charge is not moving, it is a stationary charge, then there will be no current. But if the charge starts moving with any velocity, then it produces a current, that is called the current electricity. And we can find a formula, that is q per unit time, that is the charge flow in a total interval of time, it is called the current. And if like for example, this is a wire and there are so many charge flowing in this uh, wire, then if we have to calculate the current in this wire, then we will find the total charges and for what interval of time we need. Like for example, the charge flows for a t equals to 2 second or 4 second, then we have to find the total I, that is we find the average here. The for time interval of 2 second or 4 second, that is called I average. But for instant of time, for any instant, if we have to find like at t equals to एक small time interval पे dt पे अगर हमें current find करना है, then how will we find? We will find dq by dt, that at particular this instant, at particular dt time, a small interval of time we have to find, then we will find like this. There are so many numericals as well, like we have given that there is a current q, and this is a numerical, that this is the charge that is given as 3t square by 2t. This is the charge, and we have asked to calculate the charge at t equals to 2 second. Then how will we find? We will find the, how will we find the current? Then we know that from this formula, this will dq by dt. Then we differentiate the charge with respect to time, that will be 60 plus, and we have to find the charge at 2 second, at t equals to 2 second. Then we will find 6 at t equals to 2, we will put 2, and it will be 14 ampere. This is the SI unit of current is ampere. uh, okay, so these are the basic definition. If like for a current definition, for a correct definition of current, we will give like the net flow of charge is called net flow of charge per unit time, or the rate of charge flow is called current electricity, that is I equals to qt. I hope you understand that. Now there is one more point, like we have understand that in a wire, if there is a charge q moving, then there this moving charge produce a current electricity. But if the q charge is a negative, this is a positively charged charge, If the charge is negatively charged, then like for example electron, because electron is a very important in current electricity, that in our atoms, in conductor electrons flows and that produce charge. Then if electron flows, then it produce, if electron is moving in this direction, then the current will produce in the opposite direction. This is an important thing to remember because we will need it so many times. Then you have to like remember it. If electron moves in any direction, then the current produce in opposite. The logic is simple because the positive, when the charge flow, the current produce in that direction because this charge is positively charged. If a negatively charged electron is following in that direction, then the current will flow in that direction. I hope you understand that. Like for example, for hydrogen atom, for example, if a or an electron that is moving in a circular path, for example there are many atoms, hydrogen atom as well, in which the electrons flow circularly. Then if we have to find the current in this circular path, then how will we find? Then we will find that from the basic formula of current electricity, that is I equals to, then we the basic formula of current electricity is I equals to Q per unit time. We know that here Q is our electron, and T is basic time interval. We know that the uh, time period, we can find that the distance traveled per unit velocity is called the time period. Here the distance is 2 pi r, the circumference of this circular path, and the velocity will be v. Then 2 pi r, this is the radius of the circular path, by v. Then the I will be ev upon 2 pi r. This will be the current in this circular path. This is an important formula and we have to remember this. We can also uh, find in this, but you can also remember this ev by 2 pi r. Okay, so next, now we need to some definitions. I will tell you some definitions or some terms that will help you in the further that I will explain the formula of something. Then there are some terms that you need to remember. Okay, so first is there is a uh, let this is the conductor or a wire. Here so many electrons are moving in different directions because obviously they are moving and colliding with themselves. Then the, if the electron like moving this type of things, then the distance between two success, and they are also colliding, then the distance between two successive collision, that is called the free path. That is we will denote it with lambda. Lambda is called free path, and there are so many free paths like lambda 2, lambda 3. Then this electron will collide with the another electron, the lambda 3. Then we will find its mean, that is the mean free path, that is lambda, it is lambda 1 plus lambda 2 plus lambda 3 and divided by the n number of electrons, the basic mass. This is called the mean free path. And then there is a second term, that is the relaxation time. And relaxation time, we denote it by tau. That is our relaxation time. We know that free path is called, the distance between two successive collisions is called mean free path, and the time taken between these collisions is called the relaxation time. That is the time taken between two successive collisions of an electron is called relaxation time, that is denoted by tau. And you know that in conductor, uh, This is the conductor. There are so many free electrons in a conductor. We know that. That's why it conducts electricity, because there are so many free electrons, and they are moving randomly, so randomly. But okay, now if we find the average velocity of that conductor, then it will be zero, obviously, because they are moving in so many random direction, and it will all add up to zero, and we will find the average zero. But if we connect it to a voltage, and when we connect it to a voltage, it will give an electric field. uh, Obviously we know that voltage, that is E equals to V. This is the different concept I will tell you in further, but you just have to know this much only, that if we applied it to a voltage, then there will be an electric field, and you can directly apply to an external electric field to any conductor. So let's see, there is a electric field. This is an external electric field applied to this conductor. Then this electric field applies a force on each of the electrons. We know that force in an electric field is QE, where Q is the charge and E is the electricity. This is the formula of a force in electric field. Then the force in the electrons will be minus EE, that is in the opposite. Here negative sign indicates the opposite direction from electric field, that the electric field is in this direction, then the electric force will applied on this direction. And I told you earlier that if the electron moves in this direction, current will produce in this direction. Here the electric force is applying on this direction, because electric field is in this direction. Then a current is produced in this direction, opposite to the flow of electrons, that is the I. This is called current, and it flows, basically it will flow in the same direction as the external electric field. Okay, so with this force we can find the acceleration, obviously F by m. Then the acceleration of these electrons will become E by m. Okay, so from Newton's first law of motion, we know that V equals to U plus AT, and we know that U is zero, because the initial there are will no they the all electrons were stationary, and after a time we have to find VD. This V, sorry, we have to find this V. We will name after we find the formula of this V. Then the V will be, U will be 0, A is, we have find that here, E by M. And T, what will I put the T here? I told you earlier, the relaxation time. The relaxation time, that is the time between two successive collisions. Okay, so V will become, here E is just, negative sign is just indicating the direction. So it will become E rho by, we will take the magnitude, and E. Here E is the charge and E is the electric field. M is the mass of the electrons, and rho is relaxation time that I told you earlier, and this is all. Then this velocity is called drift velocity. What is the drift velocity? We just find out that drift velocity. So basically the definition of drift velocity is the velocity gained by an electron in presence of electric field. Like if we put electric field, then the velocity gained by an electron is called the drift velocity, and this is the formula of the drift velocity. Okay, so this is all, and we can also find that V equals to, we can name it as a mu. This whole thing we can take as a mu. Mu equals to E rho by m, and we can say mu is a mobility of electrons. This is just a nomenclature, you will get used to it after some time. Mobility is just the electron द ड्रिफ्ट वेलोसिटी पर यूनिट इलेक्ट्रॉन, यहाँ से हम इसको म्यू निकाल सकते हैं. Okay, so this is the drift velocity as well. And there is another term, that is the current density as well. This is also a term, and the current density is, we will denote it by J. J is the current following in any cross sectional area per unit cross section area. That for example, there is a, this is the wire and its cross sectional area is A. We can find that A equals to pi r square, or not always, but sometimes it will be pi r square. Then the current following थ्रू दिस वायर पर यूनिट क्रॉस सेक्शन एरिया, यानी इस स्पेसिफिक इस एरिया से जितना करंट निकलता है पर यूनिट क्रॉस सेक्शन, this is called the current density J, that will denote by J. Okay, that's it. And we have learned so far about drift velocity and the mean free path, relaxation time, and the basic definition of current electricity, and how the charges flow, and how the charge flow in a conductor, and the what will be the current in a circular path. So that's for today.